Namaste students. In the previous video we have done the definite integrations, properties of definite integration, and I told you the properties would be more clear when we are going to support those properties with the examples. Alright, means where to apply which property, that is very important. Clear? So look at the first question. 0 to pi by 2 sin x upon sin x plus cos x dx. I have to integrate this. See, we apply one property. 0 to a f of x dx is equals to 0 to a f of a minus x dx. In the questions, alright, very useful property. There are three very useful properties. See, when what we did first, second, third, there can be a part of the properties. First and the second can be the part of the properties. Fine. This property 0 to f of x dx, 0 to a f of a minus x dx would be applied in such kind of questions. I have written two questions where you have almost the similar kind of things in the numerator and denominator. Alright, almost similar kind of things in the numerator and denominator. To solve such kind of questions, this property is very useful. See how we are going to apply it. I'll name it as 1. I'll apply this property. This property says this integral will be equals to the integral if I change x into a minus x. I is equals to this. This will remain I only. This will remain I only. Means this integral will be equals to sine of f of a minus x. That means if I change x into a minus x, the integral remains same. The integral remain same. Is this clear? Alright, the property says 0 to a f of x. Oh, that was pi by 2. 0 to a f of x is equals to 0 to a f of a minus x. So that means if I change x into a minus x, both are equal. So solve it. What is sine 90 minus theta? That is cos theta. Sine 90 minus theta, that is cos theta. Cos 90 minus theta, that is sine theta. After applying this property, when you change this, name it as 2. First equation you will name it as 1. Then you will apply this property that this integral will be equals to this integral by the property. Is it clear? Then after solution of this, you will name it as 2. And then what will be the next step? These are fixed steps, children, which you have to follow. Equation 1 plus equation 2. Equation 1 plus equation 2. Add equation 1 and 2. I plus I. 2i. 0 to pi by 2. If you remember the property which we did, the fifth property, when you have sum of the integrals, when you can split it, so same if the integrals are in the different parts, I can add it also. Is it clear? I can add it also. So if you see the denominators of 1 and 2, those are same. The denominator of equation 1 is sin x plus cos x. This is also cos x plus sin x, or you say sin x plus cos x. That is one and same thing. When I add it, when the denominators, that means you write it this way first of all, so that no confusion. LCM and add. So this is why this property is very important. You know, there was such a big question to integrate. When I have applied this property, when I had to integrate, I have reached to 2i is equals to 0 to pi by 2, 1 dx. That's it. Understood now how this property is useful. Otherwise you have to think so much. This can be done by without property also. Clear? But now when I have applied this property, this question has become such an easy. So that means remember the properties, the questions would be very easier for you. Alright. So what is the integration of 1? That is x. Put the limit, upper limit minus lower limit. So 2i is equals to pi by 2. I need the value of I, that will be pi by 4. Understood, children? So I have applied the property. The question has become such an easy question, and we got I is equals to pi by 4. That means the integration of this function is pi by 4. Alright, now it's clear. Where do we apply? We apply this property when you have similar kind of functions up and down, and by adding 1 and 2, the things will get cancelled. Then we apply. Now look at the second one. Again, I'll name it as 1. I'm applying that property. Alright. Cos 180 minus theta. Cos 180 minus theta. Second quadrant. Cos is negative in second quadrant. And pi does not change the t ratio. Minus of cos x. Here. Again minus of cos x. Here also minus of cos x. But minus is already given to us. It will become plus cos x. Name it as 2, equation 1 plus equation 2. The denominators are same. So I'll add the numerators. That I have shown you how it is added. First you will add, because the denominators are same. I'll take LCM. So you get the same thing. So we got the same thing in the numerator and denominator. See how easy it has become. Just remember one property and the question is just simple. Alright. So it is integration of 1 is x. It was pi. Upper limit minus lower limit. Lower is 0 only. So I will be equals to. Alright. Look at the questions. How easy the questions have become. If I remember one property, the questions are so easy to calculate. Look at the next question. Mostly we are doing the questions which are of this property so that concept is more clear to you. कि किस तरह के questions में ये वाली property apply होती है. ठीक है? Alright. So I have 0 to 1 x 1 minus x raised to power n dx. A problem ये है, I can't integrate this portion अभी. 1 minus x raised to power n. I can increase the power by 1 divided by increased power, but the problem is I have x with it. ठीक है, x है साथ में. X and 1 minus x. If such kind of combination also comes in definite integration with limits, then also we can apply the same property. I'll apply. What is the property? Alright, so apply here. I'll be changing x into a minus x. What is a? 1. I'll be changing x into a minus x. So it has become here when I'll open it, 1 and 1 cancel. Is this clear? 1 minus x raised to power 1 minus x into x raised to power n dx. Now because it was not a similar kind of question what we did previously, I said when up and down it is the same term, you can apply this property and then add 1 and 2, the question will become easier. Here there is no up and down, so you don't need to add this. If you might see what is my target? My target is to make the question integrable. I have to integrate. Now if you look at this question, if I multiply x raised to power n inside, I got it converted into simple question. Fine. So that adding concept works where you have numerator and denominator, and it is a similar kind by when we apply this property. If I add 1 and 2, everything gets cancelled. If I now add 1 and 2, nothing is going to cancel because there is no numerator and numerator is there. There is no denominator of same kind. So in this no useful here, when I apply this property directly, I come to such a step whose integration I know. Now I know the integration. That's it. Increase the power by 1. Increase the power by 1. Put the limit. If I put 1 raised to power anything is 1. 1 raised to power anything is 1. When I put 0, it will be 0 minus 0. So that's my answer. You want to take LCM and further solve it? You can do that also. Is it clear? If I take LCM, it will be n and n cancel. So I have 1 upon n plus 1 into n plus 2. So how useful this property was, right? I was not able to integrate it because x was simple and the power was of this. I cannot take this x inside. But जैसे ही हमने property apply किया तो x switch हो गया. x किसके n switch हो गया. n यहाँ आ गया और this was simple. Now the multiplication inside the bracket was very easy. So that's why we applied this property. Clear? Now look at this question. See, you can solve this question in beginning morning only we have done when we started definite integration. Sin square I can write it as 1 minus cos 2x by 2 and integrate. But with the property the question becomes very easy. You know, apply the same property. Change x into. What is sin pi minus theta? Sin pi minus theta is. Now see, adding 1 and 2 will work. In this it did not work because we come to the answer where I could directly integrate. अब यहाँ भी integrate कर सकती हूँ. I can write cos square as 1 plus cos 2x by 2. But फिर अगर मुझे यही integrate करना था तो यहाँ कर देती. Why did I come on this step? I came on this step to make the question easier. Fine. तो अब क्या कर रही हूँ? Add 1 and 2 because मुझे क्या नजर आ रहा है? वहाँ sin square नजर आ रहा है, यहाँ cos square नजर आ रहा है. अगर add कर दूँगी तो I'll get sin square plus cos square as 1. My question has become so easy. So add 1 and 2. That is 1. Alright, integrate 1. That is integration is x. Put the limit. Pi by 4. I is equals to pi by 4. Clear? So you can apply this property in such kind of questions also. Where the question was difficult to integrate, I brought it to the easier one. Here, though the integration was possible because we have done indefinite integration also such kind of questions, but with the property, the question was become easier. So you have to think if the properties would be like on your tips, you will be able to apply those in your questions. See, now in few questions you really have to think. Alright, and I told you in beginning, integration is all about thinking and practicing. Fine. Now it is I have to integrate cot inverse 1 minus x plus x square. Limit is 0 to 1. I don't know how to integrate. So I need to think. Whenever inverse trigonometric function comes, we have to think from the point of view of inverse trigonometry. We know that cot inverse x can be written as few questions you should always put a star on, you know, different questions. So I can write it as अब ना you will say अभी तो मैम न्यूमरेटर में था आपने तो और डिफिकल्ट बना दिया उसको. Alright, so that means सोचो उसको कुछ और. अब इनवर्स ट्रिग्नोमेट्री है तो इनवर्स ट्रिग्नोमेट्री का रूल तो अप्लाई होना चाहिए कुछ. Now look at the denominator. I am taking minus common from here. 1 minus AB. Tan inverse 1 minus xy. If it comes x minus y here, this will be the formula of tan inverse x minus tan inverse y. इनवर्स ट्रिग्नोमेट्री आएगी तो उसके क्वेश्चन सोचने पड़ेंगे, उसके फार्मूला सोचने पड़ेंगे. अगर नीचे बना 1 माइनस एक्स वाई, अगर ये x प्लस वाई, सॉरी क्योंकि नीचे माइनस है तो ऊपर प्लस आना चाहिए, अगर x प्लस वाई बन जाए, my purpose is solved. So what I want to do, I am going to add 1 था, 1 तो था ही, 1 में एक बार x ऐड कर दिया, एक बार सब्ट्रैक्ट कर दिया, एनी प्रॉब्लम? 1 में एक बार x ऐड कर दिया, एक बार सब्ट्रैक्ट कर दिया, बैलेंस. Now I'll split it. This is tan inverse x plus y upon 1 minus xy. That is the formula of tan inverse x plus tan inverse y. Writing the separate integrals. I know how to integrate tan inverse x by parts. ठीक है, और कोई ऑप्शन नहीं है. बट एक और साथ में है tan inverse 1 minus x. I can solve this also by parts. बट दो चीजें सॉल्व करनी पड़ेगी. कुछ सोचो. x 1 minus x. 1 is here also. So apply that property. 0 to a f of x is equals to 0 to a f of a minus x. Apply the property on this part. Because इस पे करोगे तो ये बन जाएगा. और जब हम x को सॉल्व करना आसान है ना, तो इसको चेंज करते हैं. I am applying that property on this part. Tan inverse f of a minus x. That means x की जगह पर a minus x. Clear which property I am talking about? 0 to a tan inverse x. I am writing tan inverse a minus x. x की जगह पर a minus x. So it is 1 and 1 will be cancelled, x will be positive. So both have become same. So now at least I have to integrate 1. नहीं तो यहाँ पर अगर ये प्रॉपर्टी के बारे में नहीं सोचोगे तो दोनों को इंटीग्रेट करना पड़ेगा. और प्रॉपर्टी ये ना प्रैक्टिस करोगे ना, कुछ क्वेश्चंस पता चलना शुरू हो जाएगा. बिकॉज सी 1 minus x 1 minus x अगर बन जाए तब सेम हो जाएगा. इधर से बनाओगे तो यहाँ ये बन जाएगा. सो प्रैक्टिस के बाद यू विल बी एबल टू फाइंड आउट किस क्वेश्चन में क्या प्रॉपर्टी लगानी है. Now no other option, I have to apply by parts. In I8 this is the first one, second is not there, so I'll multiply, or this 2 can be taken as second, better. Clear? So first function as it is, that is tan inverse x. Integration of second is 2, so integration is 2x. I told you in the previous one, the moment the integration is over of the first part, you have to put the limits. Differentiation of first, tan inverse differentiation 1 plus x square. Alright, put the limit here. Upper limit, tan inverse 1, 2, minus 0 when you put 2 into 0, 0, 0 into something would be 0. Here, substitution will work. X dx is equals to dt, but when I am changing a variable, one variable into other, I have to change the limit also. As x approaches to 0, t approaches to 1, x को 0 put करोगे t1 आएगा. As x approaches to 1, t approaches to 1 plus 1, 2. So it is from 1 to 2, 2x dx is dt, 1 upon t. Tan inverse 1 is pi by 4. This has become log t. Put the limit, upper limit minus lower limit, there is a minus sign outside, so become log 1. What is the value of log 1? That is 0. Is this clear? So you need to really think, children. You have to practice lots of questions. Then only you will be able to find out that which property to be applied where. Now look at the next question. Again, see few different kind of questions. Alright, where you need to practice. Now this one, log of 1 plus tan theta d theta. अब log की इंटीग्रेशन तो वैसे बाय पार्ट्स होती है, और उसके ऊपर we have something else also inside. Log का x is not a simple x. ठीक है, so I will apply this property. So what is this property? log f of x dx limit from 0 to a is equals to 0 to a f of a minus x dx. So apply. अब मैं यहाँ इसको 2 बना दूँ, अभी तो कोई फायदा नहीं है, और ये 5/2 भी नहीं है कि tan π/2 माइनस थीटा cot थीटा बन जाए, कुछ ऐसा बन जाए, वो भी नहीं बन रहा. बट आई हैव अ फॉर्मूला of tan π/4 minus theta. Apply that formula. What is tan π/4 minus theta? 1 minus tan theta upon 1 plus tan theta. Take LCM and solve it. Cancel. All right. We have a rule in log m upon n. Log m upon n. Log m upon n can be written as log m minus log n. And that's what we were waiting for. If you see question 2, I have got log 2 minus log of 1 plus tan theta. Same. Now it's a benefit to add 1 and 2. Is it clear? So 1 and 2 को तब add करना है कुछ बन रहा हो, जबरदस्ती नहीं 1 और 2 को add कर देना है. Clear? So 1 what will be left here? This and this will get cancelled. There is log 1 plus tan theta and that is minus log of 1 plus tan theta. When I add 1 and 2 in the integral, these two will get cancelled. Now integration log 2 is a constant that will remain out of the integral. That means I am left with 1. Integrate. 1 with respect to theta would be theta. Upper limit minus lower limit. This 2 will also come this side. π/4 minus 0. That is the answer. Clear, children? So questions can be different. Only one key to success is the practice. Look at the next one. Integration of x sin x upon 1 plus sin x dx. Limit 0 to pi. Almost the same kind, or we have to try this property. Is it clear? Whenever trigonometry comes, most probably we always should try this property once. Fine. So x is changed into a minus x. Because had it been this x not there, I can integrate it. You remember we have the last form that a sin x plus b cos x upon c sin x plus d cos x किया था indefinite integration का, second last topic. उससे भी हो सकता था, लेकिन प्रॉब्लम है ये x. और अगर ये ना होता, इसको कुछ rationalization कुछ भी सोच सकते थे. अभी देखते हैं. तो हमारा टारगेट क्या था, इस x को रिमूव करना. Alright, so it is sin 180 minus theta is sin theta. Sin 1 minus sin 180 minus theta is sin theta. Now I am add 1 and 2. Now when I add, denominator is definitely same. Numerator has x sin x. It is, if I multiply inside, this is also pi sin x minus x sin x. So x sin x and x sin x cancel. So my at least x is removed. One sign of relief, you know. Now pi sin x is left. Pi is a constant. I will keep it outside. So my target was to remove this x. I have removed it. Alright. Now we need to think. Now we have sign up, sign down, 1 plus sign down. So what am I doing? I'm adding 1 and subtracting 1 here. ऊपर नीचे कुछ similar हो तो add 1 subtract 1 मतलब एक जैसा बनाने की कोशिश करो अगर बनता है तो. Alright? Sin x अगर suppose ऊपर x से नीचे 1 plus x है तो ऊपर 1 add कर दो subtract कर दो तो कम से कम एक portion cancel हो जाएगा. Now if I split, one की integration तो आती है. What am I doing here? I'm going to rationalize this part. Clear? 1 की integration I know. I'll do it together. This will be 1 minus sine, 1 plus sine, 1 minus sine. That is 1 minus sine square. 1 minus sine square is cos square x. 1 minus sine, 1 plus sine, 1 minus sine square. That is cos square x. Now I can split it. 1 by cos square. Secant square minus minus plus. Sine upon cos and into 1 by cos. Secant x into tan x. These are small things, you know it by now. Now integrate. Integration of 1 is x, secant square's integration is tan x, secant x, tan x integration is secant x. You have learned the formulas by now that we presume. Alright. So put the upper limit and lower limit. When I put upper limit, pi. What is tan pi? Sine upon cos, 0. Secant pi, 1. Minus lower limit, 0. Tan 0 is 0. Secant 0 is 1. So I have pi by 2 into pi plus 1 minus 1. So pi square by 2. Is this clear? So that means you need to really think about the questions key, how to go about it. Alright? Fine. I hope it's clear to everyone. Just see if some minus. It's all fine. 1, there's no sign difference. Minus minus 1 minus sine square. 1 by cos square would be secant. Plus upper limit. Pi, tan pi is 0. Secant pi is 1. Minus 1. That's what I was thinking. Secant pi is minus 1 beta. Alright, clear? So pi minus 2 pi, pi by 2 is outside. So that would be the answer. I hope the things are clear to you, where to apply these properties and how to apply the property. I'm picking up the last question of this property. I is equals to 0 to pi, x sin x dx, 1 plus cos square. Apply. So it will become pi minus x, sine 180 minus theta is sine theta only, cos 180 minus theta is minus cos theta, but it's a square, so it will become positive only. Now add 1 and 2, because denominators are same. Now this I am writing it directly. It is x sin x plus pi sin x minus x sin x. So x sin x cancel. Pi sin x. So pi I am taking common out, not common, out of the integral because it's a constant. So how will do this now? This can be done by substitution. Clear? So put cos x is equals to t minus sin x dx is equals to dt. Substitution method is clear to everyone. Alright, when I change the variable, I have to change the limit also. As x approaches to 0, cos 0 is 1, t approaches to 1. As x approaches to pi, t approaches to minus 1. Because cos pi is minus 1. Cos pi is minus 1. Clear? Alright. So my question has become, limit has become 1 to minus 1. Sin x dx is minus dt, so minus is outside. Now we know that almost every time it should be from smaller number to bigger number. So I'll change the limit from minus 1 to 1. If I change the limit from minus 1 to 1, when I'm interchanging upper limit and lower limit, what happens? Negative sign comes outside. So this minus goes out. So this minus will be adjusted with it. What is the integration of 1 upon 1 plus t square? Remember the form? What was the form? 1 upon x square plus a square. That is 1 by a tan inverse x by a. 1 by a is 1, no need to write it. Tan inverse x by a. Put the limit. Upper limit minus lower limit. Alright. Tan inverse is 1 at pi by 4 and tan inverse is minus 1 at minus pi by 4. Pi by 2, pi by 4 plus pi by 4, that is pi by 2, so pi square by 4. Is it clear, children? So these were few questions related to one property we have focused on, that was 0 to